Hi, I wanted to take some time to go over the shunting yard algorithm. Uh, Edgar Dijkstra created this algorithm, and it is for converting infix to postfix. And you have an assignment, and that is to write a class that has a method that converts infix to postfix and another method that then evaluates that postfix notation. And it'd be helpful to write a third method that simply takes in a string in infix, calls the converting function, takes that result, and calls the evaluating function. So let's take a look at it. Let's walk through the algorithm together. So let's say that we're just going to go through the first example together. Let's say we have 15 plus 6, and these are all space separated, okay? Minus 2 times parentheses 3, 4, minus 1. And by putting spaces, it just makes it a little bit easier for us. Otherwise, we have to write some code to parse this out and, detect when we end having numbers and things like that. So, if we call this a string str, okay, that we take in, then what we can do is we can make a string array, and be called like expression, and you just want to call str.split quote space quote. All right, so I'm going to assume that we have done that, okay? And that what that does is it would make an array like this, where each one of these things, there are no spaces anymore in the array, okay? Because it splits around the spaces, thereby removing the spaces. And then finally the parenthesis. Okay? So we're going to go with that assumption that we are at that point in the algorithm that we have an array, which I'm going to call expression. Okay? So, first thing in our algorithm says that if E is an operand, we're going to offer it to the postfix Q. Now, an operand is a number, as opposed to an operator. Operators perform operations on operands. Now, it would probably be easier if, when you go through the different parts of the algorithm, that we actually make that the else portion. But we're going to call this our postfix Q, and it's a Q, okay? And I'm going to be writing new things at the top, adding new things to the bottom and pulling from the top. We're also going to have something called a stack, right? And that's going to be called our operator stack. And in the stack, again, I'm going to add new things to the bottom, but I will pop. So I'll push to the bottom and pop from the bottom, so that it behaves like a stack. So let's go through the first thing. Is this an operator or an operand? Well, this is an operator. Okay? So we're simply going to offer it to our postfix Q. So I'm going to put 15 right there. And that's done. So I'm just going to mark that that's done. Okay? Our next thing is an operand. So, an operator. Now, if we have an operator, we have to do several things. Okay? By the way, I'm just pulling these off through it with a for loop one at a time, and I'm actually letting them be a value E. All right? So at this time, E is a plus. Okay? The string plus. So if it's an operator, we have to look at the operator stack. If the operator stack is empty, we're simply going to push it onto the stack. So I'm just going to do that right now because my operator stack is empty. So that wasn't too bad, right? All right, next we have 6. We're done with this now. So 6 is an operand, right? So we offer it to our postfix Q. Okay, not too bad. Then we get a minus. Okay, so now things are going to get more interesting. Okay? All right, we get a minus now. When we have an operator, we have to look at our operator stack. If the operator stack is empty, we would simply place it on the operator stack, but it's not empty. Okay? So we have to do this. Now, this is going to be within a while loop. We're going to say while the operator stack is not empty. So that is important because we don't want to run out of operators and get an error. So you're going to see that in most cases we actually won't reach that condition because we'll use the keyword break to break from the loop. All right, so because the operator stack was not empty, we need to do something. We need to pop an operator from the stack. So I'm going to call this, let's see here. We have E as our current operator, so I'll call this op. So I'm going to pop an operator from the stack. So remember, when you pop, it returns what it is. So you'll have to catch it, right? We'll catch it in a variable called op. And it's gone from my operator stack. Now, if an open parentheses were popped, we would push it back and break the loop. But it's not. It's a binary operator. Binary operators are operators that require two operands: add, subtract, multiply, divide, as opposed to, say, factorial, which is a mono operator. All right, so it is a binary operator that we've popped. So we have to look at it. Does this have a higher or lower priority? Well, add is the priority I got. Subtract is the priority that I'm on right now. So the operator that I popped has the same priority as the operator I have. When having the same priority, and add and subtract are the same, multiply and divide are the same, right? From, please excuse me, dear Aunt Sally, or PIMDAS. Remember, multiply and divide is a tie, add and subtract is a tie. So they have the same priority, so we end up going with which one we came to first. So because we offered to our stack this plus first, we're always going to, whenever there's a tie, we're going to take the operator we popped, and we're going to put that on our postfix queue. Okay? So I'm going to go ahead and push that up, offer that to my postfix queue. Now, at this time, we should then break the loop. Okay? Actually, we don't break the loop. We don't break the loop. We don't break the loop on this one. Because we offer this to the postfix stack. Now we're going to break the loop though now because the operator stack is now empty, right? So then after you've either broken the loop or completely imperated the operator stack, we're going to put that minus on our operator stack. Okay. All right, that was a bit of work, right? That was a bit of work. But we have now handled the minus. All right, next one is a 2. Boy, I love these operands, right? Because they are easy. What do? We just offer them to the postfix queue, don't we? Okay, cool. All right, what's next? A time sign. Oh boy, a time sign. So we get a time sign. All right, well, that's an operator, so we need to while the stack is not empty, right? So while the operator stack is not empty, we're going to pop. So I popped up a minus. That's gone. All right, I need to compare the priority with this operator with my E. Well, it turns out this time that this popped operator is actually a lower priority. We should times before we subtract, right? So we need to instead, because the pop priority is lower than E, we're going to just put that right back on our operator stack. So we popped it off, then we're going to put it right back, and we're going to break the loop, okay? So anytime you pop an operator and it's not equal or greater than E, we push it back on, break the loop, and then every time you exit this while loop, the last thing you're going to do is you're going to push E. So we're just going to push E right here. Okay? All right, next we get a parenthesis, an open parenthesis. So what do we do when we have an open parenthesis? Well, if it's an open parenthesis, we don't have anything we can do yet because we got to wait till we find the end of that parenthesis. So we just push it on the operator stack. We just push it right there in the operator stack. So that's one of our conditions. Okay, moving on. So remember, if it's an operand, it goes to the postfix, open parenthesis goes on the operator stack. All right, we got another 3 next. I'll just go ahead and do that. So we're going to go to 3. All right. Then we got a plus. Okay, so you know that's when we got some work to do, right? All right, so I have a plus. That's my E. We're going to go ahead and, the operator stack is not empty, so we don't just push it on there. We got to do some work when that operator stack is not empty. So operator stack. We pop something. What are we going to pop? We're going to pop an open parenthesis this time, right? We'll pop an open parenthesis. Okay, so it's an open parenthesis. So whenever we pop and get an open parenthesis, we're just going to push it right. So when we popped it, remember it came off this stack, right? If we get an open parenthesis, we just put it right back. Okay, put it right back. Then we break the loop. And every time we break that while loop, if we do this while loop thing, after breaking, we push E on it. So we'll go ahead and push E on it. So that's a plus. Okay. All right, moving forward, we get a 4. We're going to put that right here on our postfix. All right, moving forward, we get a minus this time. Okay, now we have a minus. My operator stack is not empty, so I'm going to pop off something. What do I pop off? Well, actually, I pop off a plus, right? I pop off a plus. All right, so now when I pop off that plus, these are a tie. So whenever it's a tie, then I just take what I popped off. I know it's time to do it, so I put it on my postfix stack. Postfix queue, excuse me. And then when I'm done with that, I put, remember this is gone now. This is gone. All right, that's gone. So now I put the minus here. All right, moving on. Okay, next we get an E becomes the number 1, so it goes right here. Then E becomes a closed parenthesis. All right, when we get a closed parenthesis, we need to do another while loop. We need the loop while this top of the stack is not an open parenthesis. We're going to pop an operator from the stack and offer it to the postfix queue. So we're just going to sit there and keep pop, 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 pop until we get to an open parenthesis. Okay? So I pop and offer. So I'm popping off that minus and offering it, and then I pop off the. Notice I never put this. Closing parenthesis on the stack because we don't have parentheses in postfix. So I keep popping until I get to this open parenthesis, and when I get it, that's when I know to stop popping, and I don't put it on my queue. I'm just done with it. Okay. All right. Next, we are done. We are done going through our entire expression. So that's when you stop doing that. And then we still got some stuff left on the operator stack. So what we're going to do is we're simply going to pop it and offer. So we're going to pop the times. We're going to pop times. And I'm kind of running out of room here. And then we're going to pop minus. Okay? So then I usually tell people to just kind of form a string. Okay? This is when we're done. Okay? So str, our final string. We're just going to pull. So 15, space 6, space plus, space 2, space 3, space 4, space plus, space 1, space times, space minus. Okay? All right, so that's all that. And you're done with making that. You can practice evaluating this. Okay? I'm going to leave that there in case we want to reference it. You can practice evaluating this. You would do 15, 6 plus. That's what you would do first. Then you have to do 2 inner, 3 inner, 4 inner, plus 1 times, minus. Oh, something is wrong. We were supposed to do times only after I minused. Okay, hold on. I'm going to go back in time a little bit here. Okay, hold on. That's a minus. Okay, never mind. Couldn't read my own handwriting. All right, so we have 15, 6 plus 2, 3, 4, then the 1. Then I'm supposed to have a minus. What, 4, then a minus. Then a 1, then a minus. Okay, so I'm missing a minus right here. Okay, I can put that in right there. So 1 minus times minus. So you do 15, 6 plus. Then you got to do 2. You got to wait because you got to do 3, 4 plus, 1 minus. Then finally you multiply it to the 2. And then you subtract that from what 15 plus 6 was. So that's how that works. So next we need to see how to use a stack to evaluate this.